You are watching part 1 of rational expressions, simplifying rational expressions and also stating the excluded values. So there will be 2 problems that I'll work on, and then there'll be 2 more that you guys can work at right afterwards. They'll be right after these first 2. And then we'll go through all the stuff that we need to talk about. How do we find excluded values? How do we simplify them? And things like that. So if I look at this first particular problem, well, let's back up a little bit. Remember, a rational expression is basically saying that we have variables in the denominator. Okay, we have a fraction, and an expression basically means just we don't have an equal sign, right? So it's just an expression. It's not containing an equal sign. That's for later on this year. So if you look at this, I want to simplify. So let's simplify first, right? Get it out of the way. So if I look and I have r squared up top and I have an r on the bottom. Well, an r on the bottom just means that I have r to the first power on the bottom. So how many do I have up top? How many do I have on the bottom? You notice that the top is bigger. So what's going to happen is I'm going to cancel the like terms out, the like variables. So they each have 1 in common. Okay? So what happens is what I'm left with up top is just r to the first power, because technically r squared is equal to r times r. So if it's r times r divided by r, one of those cancel and I'm left with just 1 r left. And that's how you simplify, using variables. That's one way to do it. What I then want to do is I want to cancel out, simplify my numerical coefficients, 100 and 90. Well, if I look at negative 100 over 90, I see that these can both be divided by 10. So I get on top negative 10 over 9. So that's the numerical part. Well, what happened with my variable? My variable r was left on top. So my answer is negative 10r over 9. This is the simplified answer. But you notice the instructions, they say simplify and state the excluded values. So what are excluded values? Excluded values are numbers that, when substituted for a variable, give you 0 in the denominator. So they're numbers that get substituted in for the variable that will make the denominator 0, that will give you 0 in the denominator. Why is that a bad thing? Well, if you remember from fractions when you first started talking about them, you cannot divide by 0. If you make your denominator 0, that means that it's undefined, right, in terms of slope, if you want to think about it that way. But it's also, we can't graph it. When you start getting into the graphs, it's what we call an asymptote. Okay, you'll get an asymptote at that value. So how do we figure out this value for the denominator, for r? So what I'm going to do, this is only for excluded values. Okay, I take the denominator, 90r, and I make it equal 0. And I solve for the variable. Okay, so how do I solve? I divide by 90, and I get r equals 0. What does that mean? That means that if I plugged r to be 0, and I multiplied by 90, guess what I'd get? I'd get 0. I can't have that. I can't get 0 in the denominator. So my excluded values are when r equals 0. So you can write it that way. You can write it as r can't be 0, okay? Or you can write it as excluded values of 0. Okay? I can't have r to be 0. That is why it's an excluded value. So let's do one more example, and then you'll be able to do 2 of them by yourself. Okay, here's the next one. So first I want to simplify. if I look up here, what people want to do is they will look and say, hey, guess what? That's 8. No! In order to simplify a rational expression, you need to simplify the same type of nomial. Okay? So a nomial. So this is the way I kind of do this. So a nomial for me is the term, right? So the amount of terms. So you have a monomial, which means 1 term. You have a binomial, which means 2 terms. You have a trinomial, which means 3 terms. You have a polynomial, which just means many terms. Usually anything after 3 is just called a polynomial, but you can still call a binomial a polynomial, because technically that's still correct, but we have a specific term for a binomial. So in this case, these are both binomials. They both have 2 terms, but they're not the exact same. When I'm simplifying, they need to be the exact same. So how do I make them the same, if they can be? So what happens is I look at the 8x and I look at the 80. They have something in common. What do they have in common? They can both be divided by 8. So if I take 8 out of the 8x, I'm left with just x. If I take 8 out of the 80, I'm left with 10. Some of you might be like, well, that doesn't make any sense. What I'm doing is I'm undistributing. So if I were to distribute this, I would get 8x plus 80, which is what I had when I started. I'm just taking out the GCF. Remember, GCF is greatest common factor. So I'm taking out the GCF out of the numerator, right? And I'm taking out the 8. So now I have 8 times x plus 10 over x plus 10. Well, now it kind of looks familiar. X plus 10 and x plus 10 are the exact same thing. They're the same nomials. They're both binomials, but they're the exact same binomial, x plus 10 and x plus 10. So when I cancel them, they technically become a 1. So it's really 8 times 1, which is then just 8. Okay, so the answer, the simplified answer, is just 8. But like I did in the last problem, I need to find the excluded values. And when I find the excluded values, remember, I just care about the denominator. That cannot equal 0. What number do I have to get in order for it not to be 0? Well, I take the denominator and I set it to 0. Now I solve. When I bring this over, I get x equals negative 10. So the excluded values are x equals 10, negative. Because negative 10 plus 10 is equal to 0, and I can't have 0 in the denominator. Okay? So there's 2 more examples, numbers 3 and 4. All right, number 3. Let's simplify, and then we'll do excluded values. Okay, so real quick, simplifying. There's 3 here, there's 4 here, so that means there's 1 left on the bottom. I can simplify and divide by 10, so my answer is 8 over 9n. This is my simplified answer. Okay, that's my simplified answer. Now, what I want to do is take the denominator, 90n to the 4 equals 0. Divide by 90. N to the 4 equals 0. Well, if you remember anything about powers, what number times itself 4 times will give me a 0? Well, n equals 0. No other number that I can take a power of 4 times will give me 0, ever, okay, other than 0, because 0 times 0 times 0 times 0 is 0. So excluded values n cannot be 0. So that's 3. 4. Well, if I look here, I have a monomial and a binomial. So what I need to do is try to simplify the binomial so that I can maybe cancel out some stuff after. So 24 and 56. What can I divide those by? Well, I can divide those by, let's say, 8. Okay, so let's take an 8 out. So I'm left with 3a minus 7. So I'm going to rewrite this as 48 over 8 times 3a minus 7. Now if I look, I have, those are both monomials, one term. So I can simplify the monomials. So I can divide 48 by 8 to get 6, 8 divided by 8 to get 1. So your final answer is 6 over 3a minus 7. Notice I didn't put the 1 out front because that's just 1 times it. That really doesn't matter. So this is your simplified answer. Okay? Now the next thing I got to find is the 0, the excluded values. So again, I'm going to take my denominator. 24a minus 56 equals 0. Add 56. 24a equals 56. Divide by 24. A equals, now I'm going to need to simplify, divide them by 8. I get 7 over 3. That is your excluded values. So excluded values, x can't be 7/3. So that's your excluded value there. That's your simplified answer for number 4. If you need additional help on simplifying rational expressions, please look for the following videos.